Okay, in this absolute value inequality problem, it's a little bit different because you have a variable inside your absolute value and a variable outside the absolute value, which creates some issues from our normal algorithm we use. The method I'm going to use today is a function method, which is we're going to create a function, f of x, and that function is going to equal the value of our problem, except that we're going to get it greater than 0 or equal to 0, so we're going to subtract 4 from both sides. So we get this function, f of x equals the absolute value of x minus 3 plus 3x minus 4. Now, this still doesn't help us, because what we're eventually going to do is try to figure out when is this greater than 0. But to do that, we need to get rid of the absolute value. And the way we get rid of the absolute value is by turning it into what we call a piecewise function. And to create a piecewise function, we break it into pieces based on the zeros of any absolute values in the problem. In this case, the 0 of the absolute value is when x equals 3. So we say, what does the function look like from negative infinity to 3, the 0 of the one absolute value in this problem, and then from 3 to infinity. So now that we've established what our piecewise function looks like, we actually create the function, and all you think about is the absolute value positive or negative in the interval? If it's positive, then you just write it as it is. If it's negative, then you have to take the opposite, because if an absolute value is negative, you take the opposite to find the value of the absolute value. So in this case, from negative infinity to 3, if you plug any of those values in for x, like let's say negative 5, you get negative 8 inside the absolute value, which is negative, so we're going to do the opposite. So the easiest way to do opposite is just with a negative sign. So the opposite of x minus 3. The 3x and negative 4 are outside absolute values, so they just stay the same, so we get plus 3x minus 4. Then in the second interval, we get 3 to infinity, and so you pick a value in there, 5, let's say. Well, 5 minus 3 is 2. That's positive, so the absolute value is positive, so we write it just as it is. And then the 3x minus 4 stays as well. Simplify your piecewise function, and you get, well, negative x plus 3, so negative x plus 3x is 2x. You get 3 minus 4 is negative 1. And then for the second one, you get 4x, and you get 4x minus 7. And so from negative infinity to 3, the function is defined as 2x minus 1, and from 4x minus 7, or from 3 to infinity, the function is 4x minus 7. Now, to turn this into an inequality, we need to find out at what point is this function going to be positive. Well, a function switches from negative to positive at what we call the zeros of the function. And we want to do it's positive because we're trying to figure out when the function is greater than 0. So what we do is we look at this and we figure out where are the critical points. Well, the critical points are at the zeros. During this interval, the critical point is x equals 1/2, which is in the interval. And then for this one, the critical point is x equals 7/4, but that's not in the interval 3 to infinity, so there's actually not a 0 at that point. So if we look at a number line, the only critical point on this problem is when x is 1/2. We have to decide which one of these two regions, from negative infinity to 1/2 or from 1/2 to 0, makes this inequality true. So we pick a value. For instance, you could pick 0. If you plug 0 in for here, you get negative 3 plus 0 is greater than 4. The absolute value of negative 3 is 3. 3 is not greater than 4. So during this whole region, that inequality is not true. Pick another value, like 2, for instance, and if you pick 2, it's easy to see that you get absolute value negative 1 plus 6 is greater than 4. That is true. So from 1/2 to infinity, it is true. And so the solution for this is all the values of x from 1/2 to infinity. And if you were to actually graph this, what you would find out is that your problem looks something like this, where you go from with a slope of 2 up until x is 1/2, and then it actually gets steeper, and so you can see that from when x is 1/2, it's 0, so everything to the left is negative, everything to the right is positive. We were looking for when it's greater than 0, and so we needed the positive part, and that's why the answer is 1/2 to infinity.